All right, we're just going to continue with KSP. When we're looking at KSP, for example, silver chloride solid, this is going to go to silver ions and chloride ions. It doesn't matter if we're looking at precipitation or solubility. You know, solubility would be dissolving, precipitation would be forming. We're always going to write the equation in this way. And then we think of it as either going forward or backward, depending on the conditions. And so normally we'll have some conditions, it could be 0 and 0, or we might have some initial ions, common ion effect. Here. And what we can do is we can calculate something called QSP, which is the same thing as Q that we saw earlier, the reaction quotient. And then compare that to KSP. So if QSP is greater than KSP, then we have too many ions in solution, and so this should shift to left, which means we're going to get precipitation. If QSP is equal to KSP, then we call that a saturated solution. Saturated solution will be at equilibrium. That means our initial conditions are equilibrium conditions. Nothing should change. Well, if QSP is less than KSP, then we call it an unsaturated solution. And so if both of these are 0, then obviously it's unsaturated, and some solid will have to dissolve to saturate the solution. And so we calculate solubilities. We can calculate the solubility, you know, in pure water, or we could calculate the solubility in the presence of a counterion. Common ion. So let's take a look at common ion type of calculation here. All right, here, let's take a solution. This is going to be 0.100 molar. And we'll do 50.0 milliliters, 0.100 molar silver ions. This would be like silver nitrate or something. And to that, we're going to add, we're just going to add 1 drop of 6.0 molar HCl. And then see what happens. And so this would be an example of like a QSP type problem. When I mix this together, is the solution going to be saturated, unsaturated, supersaturated, and precipitated? And so the first thing we have to do is we have to figure out the new concentrations. So we're going to end up with a total volume of 50.05 milliliters. And we'll have to get the HCl concentration. The HCl concentration is going to be 1 drop will count as 0.05 milliliters. So it's going to be a 0.05 to 50.05 solution of 6.0 molar. The concentration changed slightly, the HCl, or actually not slightly, significantly. This is a pretty big dilution. And so can someone calculate this out and then tell me what you get? .99 times 10 to the -3 molar. Then we calculate the silver ion concentration. This is going to be a 50 to 50.05 dilution. So this one doesn't change that much. 12.100 molar. Concentration here. Sorry. So 0.0999 molar. All right, and then we call this, the HCl is going to be the same as the chloride concentration. So this would be the initial chloride concentration, this is going to be the initial silver ion concentration. We calculate QSP. QSP, we just multiply these together. That is, it's just going to be the initial silver ion concentration times the initial chloride concentration, which gives us what for QSP? Okay, 5.98 times 10 to the negative 4. And then we compare it with our KSP. Our KSP for this is, we look it up in the book, it's 1.8 times 10 to the minus 10. And so we see that QSP is much greater than KSP, which means we have too much product, which means we're going to have precipitation occur. And therefore, precipitation will occur. So how much precipitation occurs? Do you think I'll precipitate all of it? Now, in order to precipitate out all my silver ion, how much chloride would I have to add? All of it. If I wanted to precipitate out 100% of my silver ion, how much chloride would I have to add? Well, I can look at this. The KSP has to be maintained. This is going to equal the silver ion concentration at equilibrium times the chloride ion concentration at equilibrium. And so to bring the equilibrium silver ion concentration down to 0, the chloride ion concentration has to go up to infinity. So it's not possible to precipitate out all of it, but maybe I can get most of it out, or at least some of it. And so we want to figure out how much silver precipitates or will precipitate. How much of the silver precipitates? Well, any kind of solubility precipitation question, we always use the same equation. It's going to be the KSP equation. And so here, we wouldn't write it backwards, because backwards is actually precipitation. We just think of this as shifting to the left. And so if we start off with our initial concentrations, the initial concentration of silver ion is 0.0999, is that right? And the chloride is 5.99 times 10 to the minus 3. Then this is too big, and we have to lose some as precipitate. And so minus X would be the moles per liter that precipitate out here. And so in equilibrium, we're going to have 0.0999 minus x, 5.99 times 10 to the minus 3 minus x. Okay, this is the amount per liter of precipitates. So we can plug this into the KSP equation. The KSP equation is going to be the silver, actually I just wrote it up there, so I'm not going to write it here. It's just going to be this, 0.0999 minus x times 5.99 times 10 to the minus 3 minus x. Can we use the simplifying assumption here? No. So how would we solve this? It's going to equal 1.8 times 10 to the minus 10. Well, basically, we just use the quadratic, solve it, right? But even if you use the quadratic to solve it, sometimes we will run into trouble. The trouble that we run into is this. When we're looking at dissolution, the K is very